I am starting taping if you are going to be naughty. Here we go. Let's do these together if you want. They are Algebra 1. I just need to make sure that you remember all of your tools from Algebra 1. How do I get x by itself? I'm going to move the 4 over, so I'm going to get 3x equals 12. How do I get the x alone? Divide by 3. X equals 4. Nice and easy. Okay, there you go. Next one. I need my x's together on one side. Don't let them freak you out. You know how to do this again. It's like we're back to those days in 8th grade for some of you, in 9th grade for others. 3x equals 12. Look at it again. X equals 4. No, it doesn't. And as a matter of fact, it should have been. That would have been nice. X squared equals 45. X squared equals 9. X equals 3. And you're like, yay, I'm a genius. You would have gotten points marked off on this last one. Why? Plus or minus. We got a squared. So we have 2 answers. That's going to come into play tonight, right? So, you know what I love most in the world. I love things that look hard that are not hard. Because this is where we're heading to tonight. We're going to eventually do problems that look like this. And it's like, we're going to be solving this. Once I show you how, you're going to be like, oh my God, can this be any easier? And it can't. So the first thing that we need to talk about is this. How do we solve an equation that looks like this guy right here? So I'm going to move this here. This equation, how do we solve it? What we're doing is we are getting x by itself. And the way we do that is we use our friendly neighborhood unit circle. So grab that baby out. You need it for tonight. You ready? Got those unit circles out? Ruth has a unit circle out. Get your unit circle out, please. Everyone's got a unit circle. You really do need a unit circle out. I'm not lying. Get your unit circles out.
4, 3, 7.
Get your unit circle out. I know where it is. So, how do we actually figure out what our answers are for x? You know what you do? You go backwards. I'm saying go to your unit circle, find all of the possible angles that will give you cosine is negative root 2 over 2. So right now, look on your unit circle. Look at your cosines. That's the first number of the 2. Find the negative root 2 over 2s. Find them with your neighbor. One should be, I think, is it 135? And there's another one. Ladies, stay with me. I just because I'm taking the other one. I think is it 225? Yep. Guess what? That's how we solve these. We use it. We go backwards. We go backwards. Now, there was something else to this problem that looked like this. And you're thinking, Miss T, what the hell does that mean? Here's what I need to tell you. 135 and 225 are the answers I want for this. Because they're what's on your unit circle. But you know you can go around the unit circle more than one time. So it is possible that you wouldn't just get 135. You could also get 135 plus 360 and get 495. You could also add another 360 onto it and get, I think it's, let's do it, 360, because I can't add in my head. It looks like 855. You could keep going around your circle infinite times. We don't want to do this. So what this tells you is just go around one time, right? Just go around one time. Sometimes in classes, they even make it smaller. They might even say, hey, just go around a half a time. I don't even need you to go around the whole time. For me, we're going to go around one time. Is that cool? So Is it possible you could have more answers? Yeah, if you keep going around in your unit circle over and over. But we're not going to do that tonight. So let's step up our game a tiny bit. Here are the rules. If you want to write the rules down, this is the easiest thing that we do in trigonometry. Here's what it says. Number 1, use algebra to get the trig and the angle all by themselves. And that's step 2, use your friendly neighborhood unit circle to go backwards. And step 3, be proud of yourself for getting the right answer. So here's what I want you to imagine. Oh, in a minute. We're not going to do that yet. I'll let you write this down. You don't even need to write this down. You can write this part down. Be proud of yourself. Okay. So let's start. Step 1. Is the trig and the letter alone? Yes. In this case, I've already done that for you. That's step 1. Step 2 says, go to your magical unit circle and find out where sine is -1. Do that now. That's how we get x by itself. So you're looking, there you go. I'm stealing it from Chris. Chris says that's 270. And he is right. And that's your answer, right? That's how you solve this equation. Let's step up our game a little bit. Let's make it a little trickier. Not a lot trickier, a little trickier. How about this one? Sine of x equals 5. Go to your unit circle. Find where sine equals 5. There is nowhere. Because when we graphed this, the biggest number we got was 1, and the smallest number we got was -1. So I'm warning you, tomorrow we might get a number of no solution, right? And that happens. Those, again, are called extraneous answers. That's where it's like, yeah, that problem doesn't work, you see. And that happens. That happens. Just don't want to freak out when it happens tomorrow. It won't happen today. Ooh, I love this next one. Secant is not on our stupid unit circle. So let's change it to words that are on our unit circle, like 1 over cosine equals 2 over 1. Still not super helpful because our unit circle doesn't have 1 over cosine. So we're going to use what's called the law of proportions. When you have two fractions equal to each other, if you mess with one, you can mess with the other and they're still equivalent. So what I'd like you to do on this one is flip the first one and then flip the second one. That's the law of proportions that lets us do that. Flip this guy and flip this guy. There should be 2 answers for this guy. Where does cosine equal 1/2? It should be something between 0 and 90 and something between 270 and 360. 60, and I think the other one is going to be 300. Is it 300? Yeah, nice. Look at me doing it without a unit circle. Yeah? So far, so good? Okay, what happens now when we hide it? So I want you to think of it this way. If you saw this problem, I'm going to do it like this. You don't have to write this. 6x plus 7 equals 10. That would not panic you. You'd be like, algebra 1, Miss T, light work. So now what I want you to think about it is this. Imagine this guy, this X, has a tattoo on it, right? And his tattoo is sine plus 7 equals 10. Here's what you would do. You would do it the exact same way. Even though your X is tattooed, you get it alone. So what I want you guys to do is get this piece alone using all of the algebra 1 that you know. Get rid of the 7, divide by 6, and then this problem is super easy. Super, super easy. But it looks hard. It looks scary. I love problems that look hard and are not.
When you tattoo the X.
I put the little sign on the X.
The sign is tattooed onto the X.
Yes. So they're together.
Oh,
And then the last step is to
sine x equals
is
1.
to remove the
Super
tattoo.
easy. This is like algebra 1.
I love this
So
stuff.
it's 150.
I'm not gonna say it's easy.
And it is easy.
150 and third.
Yes, 30 and 150. 30 and 150, is that what we're getting?
I know.
Yeah.
There you go. Isn't this easy? It is. So that's what's cool is that it all works, right? How about this one? Whoo! Here's a problem.
Oh, I don't like it.
Nah, it's gonna be fine. And here's my issue. My issue is this. Your unit circle has not just 1/2s and 1s. It's got some weird ass numbers on it. And I need to make these problems more interesting than using the same numbers of 1/2 and 1. So let's do this. Let's get this guy all alone. Look, that square root is not over the cosine. So do exactly what you did on the last problem. Everyone's doing this. You're doing the exact same thing that you did on the last problem. So be careful. It's not over the cosine. Look at this. I want to be really careful. He's not over this guy. You see what I'm saying? He's his own person. Move the 3. Divide by root 2. Divide by root 2.
Oh.
We're doing this new one. Don't let it fool you. Divide by root 2.
If I'm not on root 2, this is just root 2.
No. So watch what happens. Root 2 over 2. Guess what? I got to think of ways to get more numbers in there. We got root 2 over 2s. I got to get those in there. So here's what I got. -3, root 2 times cosine theta equals 1. Divide by root 2. Divide by root 2. I'm not allowed to have that. I got to move them up to the top. Root 2 over 2. Guess what? That's easy. Look on your sheet. It's going to be 45, and I think it's 315. Yeah? I got to use more numbers. I just can't keep using 1/2 every time. But I got to have them on the stupid unit circle, so I don't have a lot of choices. Okay, how about this guy? Now, I'm going to show you what this problem might look like without, oh, can we change that to a 16, please? Change that to a 16. Everyone change that to a 16. Change that to a 16. You know what? Because if you didn't do that, you would have gotten an I. And we don't want to do that. So look at this problem. Would this be scary? Would you know how to do that problem? You would. So do it in the exact same way. Get this guy all by himself. If you want to stop at that point, and I'll tell you what to do to get rid of the squared, we can do that. But I think you actually know what to do. You ready? The square. Divide by 4.
Let's divide by 4 first.
So we both sides.
Oh. I can't.
Beautiful, beautiful. Now careful. There will be 4 answers. Why 4?
Oh, you're not. This is.
Because it's positive and negative root 3 over 2. Does that make sense?
Oh.
So we got to all of them. Nice, nice. And then we'll also have a negative one. So now find them all. Find them all. There are 4 answers to this problem. What the holy hell? How come there are 4? Let's see why. Let's do it. Here we go. I love this problem. I'm going to get the 13 on the other side. Oh, I don't like that. Here we go. We're going to say sine 4 sine squared x equals 3. Sine squared x equals 3 over 4. Square root, square root, square root. Sine equals root 3 over 2. And many of you felt pretty cocky at that point. But anytime you square root something, you get a positive answer and a negative answer. So my lambs, go to sine. Everywhere you see a root 3 over 2, it's all of them. It's not just 60 and 120. It is, I'm looking at someone's answers here. What are the rest of them? 240, 300? Because you're fired. Because you're fired. One last one, and I'm shutting up. I told you light work. What do we do tomorrow? We do a little factoring with this, and it's easy. Talk to me, Anna. Oh, so are you cool with this step right here? Did you get to 3/4? Yeah? And then I'm going to square root this side to get rid of the square. I split it up and made it square root of this, square root of that. I don't know the square root of 3, but I know the square root of 4 is 2. And then remember, positive answer, negative answer. Got it. Last one, best one. Okay. Before you dive into this problem, I want to show you something. Everyone's watching me. Mateo's watching me. Imagine this problem looked like this. 8x minus 16 equals 2x minus 19. That would not scare you. You would ask for this by your x's. You move the numbers over. Don't let the fact that x has a cosine tattoo fool you. You're going to get all your cosines on this side, all your x's with the cosine tattoos, all your numbers on the other side. Don't let the fact that your x has a cosine tattoo stop you from treating it like you would any other x.
Because there's like reels that are like guys like one last. So instead they got you guys, you like go.
Colton, do this problem. You know one? Well, now do it with the word cosine in it, baby. 6 cosine equals negative 3. Divide by 6, divide by 6. Cosine equals negative 1. 12240.
I said my dad coin.
Okay. Skip the first 2. Do the next 10. They are fast. You will be done. I get the little flippy thing. And we have one last thing tomorrow to factor these babies. And we are done. Goodbye, people who are listening at home.